In this video, I want to introduce the concept of cooperative game theory and how the Shapley value fits in within this theory. So we have a group of people that cooperate in a game. Say we have the Argentinian football team with Dibu Martinez, the goalkeeper, Otamendi, Palacios, and Messi, and they cooperate to win the match against France. And the result of this match makes them the winner of, say, $1 million. So here we have the players, which are these guys over here, and we have the game, which is the match, Argentina against France, and then we have a reward, which is $1 million. The question is, how should we distribute this $1 million fairly? Should we divide it equally among the 4 players? That perhaps won't be fair for Messi, who is the best player in the world. So in principle, we'd be inclined to think that most of that reward should go to Messi. But hang on a second, because Messi can be amazing, but without Dibu Martinez covering the rivals' shoots, we wouldn't have ended the match the way it ended. And in case you're wondering, the match ended 3-3, and Argentina beat France with penalties. So we can allocate the reward fairly among the players by using Shapley values. Or in other words, a Shapley value is the portion of that reward, the portion of this $1 million that could go to each player. The main intuition behind Shapley value is that we want to determine the player's contribution to the coalition. But how can we do this? So what we could do is remove one player from the coalition and then see what happens. So in this case, we take Messi out of the coalition and we see the result of that match. If we take Messi out, this coalition obtained a result that awarded them only $500,000. So then we have reason to believe that it would be fair to give Messi the other half of the $1 million. Well, hang on. Now we take Dibu Martinez out of the coalition and we see that the result of these games deteriorates even further to the point that the reward is now only $0.1 million. But hang on, let's put Messi back in to the coalition and see what happens. So now we put Messi back into the coalition and now we see that the result of this game makes this coalition the winner of $0.3 million. So having Messi increased the reward by 0.2 million here instead of 0.5. So what is the fair reward for Messi? Should we give him 0.5 million or 0.2 million? Well, we could take the average, right? And in fact, that is what we'll do. The fair reward is obtained from assessing each player's contribution to each possible coalition and then taking the weighted average of that contribution. So if we want to determine Messi's contribution to that particular game against France, we'd first obtain the results for each possible coalition of players, and that consists on each possible coalition of 1 player, 2 players, 3 players, and also no player at all. So we make all these coalitions and then we determine the results of the game for each one of these teams. And then we add Messi to each one of the coalitions and we can obtain the contribution that Messi made to that coalition by calculating the increase or the decrease in the reward when he was added to each coalition. This is what's called Messi's marginal contribution. So finally, we are going to take the weighted average of Messi's marginal contribution to determine what could be the fair reward for this player. If this is too abstract, don't worry, we're going to calculate this manually in later videos. Here I wanted to give you an intuition into game theory and how to calculate fair rewards. But how does this relate to machine learning and understanding how the features contribute to the model's prediction? Well, in machine learning, The players are the features. The game is the prediction, and note that each prediction is one game. And the rules are the model. We haven't talked about rules yet, that will come later. But in game theory, we have basically three components: the players, the game, and the rules. So by looking at this example, now instead of the football players, we have the variables that in this case describe the characteristics of a person, for example, age, experience, whether it's a homeowner, and the degree of education. And then we have the model that will predict the income of this person. And we want to understand how these different features contributed towards the final prediction. As in, what's more important to determine this person's income? Its age, the experience, the education level, etc. So this is what this whole section will be about. We are going to model the feature's contribution to one prediction using SHAP, which is based on Shapley values. And I want to stress again the word model because I want to kill the idea that SHAP and Shapley values are the silver bullet for interpretability. They are just another way to model the feature contribution. So in the next video, I will introduce the Shapley value in more detail and the assumptions that it makes over the game and how the different players play in to determine a fair reward of the distribution among the players in the game. So see you there.